Welcome to Office Hours with Bill Jennings from Klamath Community College. In this lesson, we're going to talk about solving radical equations. So, to be successful here, we're going to assume you understand how to manipulate radicals from previous studies, but now we've got radicals landing inside of equations, and we'll talk about manipulating them a little bit. But before we get into it, we need to have a basic background of if you were to look at this expression here, and I said it'd be really nice if I could get rid of that radical sign. And what I really need you to know is that if we could just square that, I would have the square root of x squared, or the square root of x times the square root of x. At the end of the day, I would just get an x. Now, we can't just randomly go about squaring something unless we provide a legal way of doing it, which in this case, if you square one side of the equation, it will be legal to square the other. And so if I had a third root, is it fair that I could say that if I could just simply raise this to the third power, that then this and this would take care of each other and I would get an x? And if I had an x to the fourth, I could deal with that by raising it to the fourth power, leaving me with an x. And that's what we need to basically have squared away with radical equations. Now, one thing that causes trouble in radical equations is that when we square something, we potentially introduce an extraneous solution, and this only happens under even powers. And the reason why this comes about is that if we talk about saying, if I had the square root of x equals 5, it's just a simple little logic question. What number would you take the square root of that would make 5? We all know the answer is 25 for x. That's what we need to be. And what we're going to propose is if you just simply square this side and square that side, you'd get x equals 25, and the answer is very obvious. There's not much trouble there. But the problem comes about is that if someone had written down for me the square root of x equals negative 5, logically, we could look at this and say, what number do you have to put in for x that would make, if you took a square root of it, you'd get a negative 5? The only way is an imaginary answer. But yet, if I was to take and say, well, let's just square both sides, and let's square this side, I would actually produce the same answer of x equals 25, and yet we know that's not the answer. That's why we have to check our answers when you square both sides. You introduce an extraneous solution. If this problem originally had been given to me, while I could produce an answer, the answer is incorrect, and I must check my answers back into the original problem, plug this back in, and say, does the square root of 25 equal negative 5? No, it does not. So that is not a solution. I would have to throw it out. We must check our answers in all cases when you use the square root. Or a fourth, if you're getting rid of the square root and you square it, you must check your answer. If you're using the fourth root and you raise it to the fourth power, you must check. If it's an odd root, remember, odd roots don't have imaginary problems. So if you have an answer, a cube root, if you raise it to the third power, you don't actually have to check your answers. Checking your answer is always a good idea, but it doesn't become mandatory at that point. So if I had something that looks like this, that's how I could simply look at it as being squaring both sides. Now, let's talk about this just for a minute, because we've talked about how to identify a type of equation, and each equation is going to have its own set of algorithms. When we had polynomial equations, it was all about getting everything on one side, setting it equal to 0, and then trying to factor it. Now, this is a radical equation, and it's identified as being radical from the standpoint that it has a radical in it. Now, radical equations, the strategy for solving radical equations is going to be all about isolating a radical and getting rid of it. The thing that's causing me all of this trouble is that radical that's laying down inside there. So what I really want to do is I want to get rid of that radical, and my radical removal tool is through squaring both sides of the equation. If I have this radical isolated on one side of the equation, I can remove it by simply squaring that side. And if I square that side, I'll have to square this side. And then I live with the consequences of whatever the results are. Now, the whole point of squaring the left-hand side of the equation was to get rid of that radical. So I end up with 20 minus 8x equals x squared. The x squared came from the fact that I have to square both sides of the equation. I no longer have a radical. I'm not solving the equation. I'm getting rid of the radical and seeing what I create. And then I'm going to have to use my other strategies to finish the problem. By getting rid of the radical through the squaring of both sides, I've created a quadratic equation. Solving quadratic equations, we need to set it equal to 0. It's going to be a lot easier on this problem if I move this over here because I've got the x squareds already positive. So I'm going to say 0 equals x squared plus 8x minus 20, and I get that by subtracting 20 and adding 8x, and I'll do that to both sides of the equation is how that lands over there. So now I've got 0 equals x squared plus 8x minus 20. If I can't factor, I can plug it into the quadratic formula, or in this one, I could probably complete the square, but it is factorable. So let's just cut straight to the chase and factor it and go with it. So x, it looks like I'm going to create x plus 10 and an x minus 2. Now I can say x plus 10 equals 0 or x minus 2 equals 0. This is going to imply that x equals a negative 10, and this is going to imply that x equals 2. Now, so this is my proposed solution. If I jump too fast and I put that in as my answer, I'm making a mistake because I must check my answer. So let's look at our answer. How does it check out? My original question was 20 minus 8 times x equals x. So let's plug that negative 10 in. Well, here's a negative 10. Here's a negative 10. This is saying that the square root of 20 plus 80 equals a negative 10. Well, that is the square root of 100 equals a negative 10. Does the square root of 100 equal negative 10? No, it does not. So my negative 10 is an answer I'm going to have to throw out. Now, just because I threw that answer out does not mean that I'm going to throw out all of my answers, so I must check the next answer also. I had the square root of 20 minus 8, let's plug a 2 in, equals 2. That's what we're saying the original question was, where this was the x and the x, I'm just plugging in the 2. So this is saying that the square root of 20 minus 16 is 4. So this is 20 minus 16 is 4. Is the square root of 4 equal to 2? Yes, it is. 2 equals 2. So this answer checks. So my final answer, x equals 2, and that's going to be my solution. Now, I proposed there was going to be 2 answers, but there ended up only being 1 because I had to throw one of them out. Now, this problem here gets a little bit more complex because I see a radical, and it looks like I've got my radicals isolated on one side, and so someone says, well, let's just come along and let's square this side, and we'll square this side. Now, be very careful here because this is a bad strategy. We have a minus b squared equals some number c. We just think of this as being the a, think of this as being the b, and that being c. If you have a minus b squared, I need you to recognize that that becomes a squared minus 2ab plus b squared, because a minus b squared really is a minus b, and you multiply it, it's going to make this nasty thing. Well, it doesn't look that bad here. Put those radicals in, we're going to make a complete mess. So what I want to do is I want to isolate one of those radicals, and then I'm going to square, and I'm going to get rid of them one at a time, and then we'll progress on down the line. So I'm going to go ahead and leave this guy on this side, and then I'm just going to add the square root of x minus 3 to both sides. And so then I'll end up with that equals 2 plus the square root of x minus 3. So in essence, what I've really done is I've taken this guy right here, and I've moved him to the other side. He was minus on the left, so I'll be plus on the right. Now, let's go ahead and square both sides. Now, you'll find that I'll get rid of one of them, but not the other one. So I've got to square both sides. So the whole reason why I squared this was so I would get rid of the radical. So this turns into x plus 5 equals. Now, something that might be very beneficial for you here is to actually write this out so you can actually see the math that's happening. Because remember that when you square a binomial, it really means this times this. And I need to be able to make sure that comes out. So my x plus 5 is living with me over here on the left. Let's go ahead and draw lines so we can see this come about. 2 times 2 is going to make 4. And then in the middle, I'm going to get this and that. That's, you know, kind of the we call it, we could call it expanding or foiling if you want to use that word. 2 times this and 2 times that. Notice it's the same thing. So it's going to be plus 2 square roots of x minus 3 plus 2 square roots of x minus 3. And then on the tail end, so to speak, I'm going to have this times that. Well, let's think about that for a second. That is the square root of x minus 3 times the square root of x minus 3. That's kind of it squared, which is going to produce just an x minus 3. So I got rid of that one radical. That's really, really kind of nice. So what do we have? Let's clean house just a little bit. I've got x plus 5 equals 4. Well, I guess that 4 and that negative 3, let's combine those two things together. That's going to be 1 plus this turns out to be 4 square roots of x minus 3. And then I've got this x hanging out with me. Now, I started with a radical equation that had 2 radicals. I isolated one of them and squared it. Now I have an equation that has 1 radical in it. So can I isolate that radical? And then let's maybe go through the process again. So I could subtract x from this side, subtract x from that side. Something good's going to happen there. And then I subtract 1 from this side and subtract 1 from that side. Let's see what we have. Well, this reduced itself away, and so I end up with 4 equals 4 square root x minus 3. That's all that's left behind there. Now I can divide both sides by 4, and I'll end up with the square root of x minus 3 equals 1. I've got a nice little radical equation to finish out with. I've got a radical set equal to 1. It's all fine from there. I just simply square this side, and I can square that side, and I'm going to be left with x minus 3 equals 1. That was very convenient. X equals 4. And it looks like that's my answer. But I am not done yet. I must check my answer. I might have done all this work to find an answer that doesn't actually work out. We need to go back up to the original question, right up here to the very beginning. I have a proposed solution of 4. Let's see how it works out. I'm going to go right in here and plug this 4 in. So there should be a 4 that goes here, and there should be a 4 that goes here. So I end up with the square root of 9, and that 9 comes from 4 plus 5, minus the square root of 4 minus 3 is 1, equals 2. And it's kind of a question at this point. Is that really true? Well, 3 minus 1, because the square root of 9 is 3, square root of 1 is 1, 3 equals 2, and that does check. So my answer, my solution to this question, right from the very beginning, I'm going to say that my solution to this question right here is going to be the answer of 4. So there is my solution to that answer through all that work. Now, let's just set up and look at a couple of other ways that this could happen. Now, the third root, to get rid of a third root, we'll raise something to the third power. So in this case, on this one, what we would want to do is we would take this guy right here and we would take and say, okay, well, let's just get rid of that third root, so we'll raise it to the third power. So we would have 4x plus 5 equals 27. And then it's just going to be simple algebraic techniques to finish that one up. Now this one was a third root that we raised to the third power. No extraneous solutions are going to be introduced. It's possible I could get a negative answer out of a third root. So I don't have to check my answer, but it's always a good idea. Now, this one here is a fourth root. Now, this one's kind of nice because I have 2 radicals, but one's on one side and one's on the other. And actually, if I just simply raise each side of this equation to the 4th power, I'm going to go ahead and cancel each radical at the same time. I'd get 6x plus 7 equals x plus 2, and I've got a nice linear equation to finish up to find a final answer. Remember, on this one, the work isn't over until you check your answer because it was an even radical that you raised to an even power. It's possible that I could be introducing an extraneous solution here, so you must check your answer on that one. Thanks for watching, and we'll catch you on the next video.